Hey Finxters, today we will be discussing the mutable default argument in Python. Before proceeding further, let's discuss the purpose of this discussion. Python newbies often come across a common confusion while using a default mutable data type as an argument in a function. Now let's discuss this in our programming screen. So as you can see, we have a function named confused, which accepts two variables, a and e. A holds a value that will be passed to the function, and then e is the default argument, which holds an empty list. Now we append the value of a to the list e, and then we return the list e. Therefore, when we use the print statements, in the first case we call the function confused by passing the value 10. That is, a will now hold the value 10, and when we append the value a to the list e, it should return 10. Similarly, in the second case, we expect the output to be 20. So basically, what we expect is 10 in the first case and 20 in the second case. But does that happen? Let's have a look. And there we go. So that's not the case. We have 10 in the first case. That's okay. That's what we wanted. But when we call the function for the second time, the output is 10 and 20. Now, why does this happen? To explain this, I want to remind you one of the thumb rules in Python. Everything is an object in Python. This means that unlike some of the other programming languages, functions in Python are regarded as objects and not just a block of code. So, that brings us to some of the most important concepts that we need to know to understand why there's a variation in our output. These concepts include mutable objects and immutable objects and pass by object reference in Python. We already have an article which discusses the concept of pass by object reference, and I highly recommend you to have a look at that article. So let us discuss the difference between a mutable object and an immutable object in Python. Since everything is treated as an object in Python, every variable has a corresponding object instance. Therefore, whenever a variable of a certain type is created, it is assigned a unique object ID. The type of the variable, which is considered as an object in Python, is defined at the runtime and cannot be changed. However, the state of the variable can be changed if it is mutable. That means the state of mutable variables can be changed. But if the variable is immutable, then we cannot change its state. Now, the table on the screen lists the immutable and the mutable objects available in Python. That makes our life easy. And the reason we get an unexpected output becomes self-explanatory. Yet, I will be explaining that to you on the programming screen. For that, we will be using a line of code like this. We simply used the default tuple. You can check the state of a default argument, which is the empty list e in our case, using the default tuple. We are printing the state of our empty list using the default tuple for the particular function call. So this means when we call the function 1, when we pass the value 10, then the output should be a tuple representing e, which holds the value 10, and the second print statement, which calls the function for the second time, should hold a tuple holding the values 10 and 20, as we can see on the output screen, and it should do so for the function call number 2. So let's check that out, and there we go. The state of e is 10 for the function call number 1. So this is a tuple which holds the value 10, or the list which contains the value 10, and for the second function call, the list e has the values 10 and 20 contained within a tuple. This is done using the default tuple. I hope this was clear for you and was a nice dry run to understand the things better. Now that brings us to the solution. Thanks Truthfully, the solution is quite simple. We can use the none keyword in place of the mutable default argument and then assign a value to the mutable object within the local scope of the function. So you can check the values for none instead of directly assigning them to the mutable object, which is a list in our case. So let's have a look at that. Let me remove the unnecessary piece of code. Let me clear the output screen. Now instead of passing the empty list, we will pass the keyword none to E, and then we will define a condition if E is none, which is true. Then we append the value of A to the list E, and then once it's done, we simply return E. Now let's check the output, and we have an error. Okay, I know what I did. I forgot to define the empty list, and that should do it for us. Now let's check the output, and there we go. We have the solution. So that's what we expected. Now that brings us to a similar confusion with closures and late binding. Now the terms closure and late binding might be quite alien to you if you are a newbie in the world of Python. Do not worry, I'll be explaining these to you. Let's talk about lambda functions. Lambda functions can lead to similar confusions when you are dealing with closures. So what's a closure? A closure is something that occurs when a function tries to access a variable outside its scope. So given on the screen is an example of a closure. It is evident that the function foo depends on the variable message outside its scope. As you can see on the screen, that message is not within the function foo. Instead, it is inside the function func. So this is a clear example of a closure. Now things become a little complex and confusing when it comes to late binding of closures. The Python guide states that Python's closures are late binding. This means that the values of variables used in closures are looked up at the time the inner function is called. So what does that mean? I know this is quite confusing. Do not worry, I'll show that to you in the programming screen and things will be crystal clear. So let me clear out the screen. Let me clear out the output screen. Now let's write a program. So we have a function by the name table. Then we define a lambda function and then return it. So the lambda function is lambda x I into x for I in range 1, 6. Now that we are done with the function, let's print this. We have our print statement. Now we have a which passes the value 2 into the lambda function for a in the function table, and that's it. So here we have a lambda function which receives the value passed by a, which is 2 in our case, and then it multiplies 2 with I such that I is within the range of 1 to 6. So 1 is included and 6 excluded. So we expect an output which prints a list containing the numbers 2, 4, 6, 8 and 10. So that's pretty much the table of 2 until 10. We are not going beyond that because that's not the purpose of this discussion. So let's run this program. But that's not what we expected. So what happened here? Something similar to what happened previously. As I said, Python's closures are late binding. This means that the values of variables used in closures, which is this loop in our case, are looked up at the time the inner function is called. So what does that mean? That means the lambda function does not receive the value of I until the for loop has finished execution. This for loop has to finish its execution, and then the lambda function will receive the value of I. So the lambda function executes 5 times such that every time it gets the value of I, the final value of I is 5 every time. So what we get is I into x, which is 5 into 2. So 5 into 2 in the first case, 5 into 2 in the second case, 5 into 2 in the third case, and so on. That's why the variation in the output. Now you might be thinking, what is the solution to this? Since it is a lambda function and this is not what we did previously. But the solution is quite similar to what we did previously. We will simply bind the value of a default argument to the closure. So what do I mean by that? Let me show that to you. I'll define an argument, a default argument to be exact, and I'll bind it to the closure I. And that's it, we are done. Now instead of I, we have the default argument into x. So that's all, that's what we need to do. So what did we do here? We bound the closure to the arguments immediately by creating a default argument, which is arg in our case. So let's check the output, and there we go. We have the expected output. I hope you found this video useful. If so, please give it a like and subscribe our channel. Thank you. Goodbye for the day.